All right, this video is on the probability of compound events. When we look at simple probability, the probability of a simple event is a ratio of the number of favorable outcomes for the event to the number of possible outcomes of the event. The probability of any event A can be expressed as the probability of A is equal to the number of favorable outcomes divided by the total number of possible outcomes. When we talk about the outcomes of simple events, it counts the outcomes. So examples would be one dice or one die. There are 6 possible outcomes. One coin, there's 2 possible outcomes. One deck of cards, there are 52 possible outcomes. And one fair number cube, which is very similar to a die, there are 6 outcomes. When we talk about the probability of compound events, a compound event consists of 2 or more simple events. Examples, rather than just rolling one die, you're rolling one die and tossing a penny. You're spinning a spinner and drawing a card. You're tossing the 2 dice at once. You're tossing 2 coins. So even though the coin is being used, or only one coin is being used, or only one die is being used, you can be a compound event because they're 2 separate events. When the outcome of one event does not affect the outcome of a second event, these are called independent events. The probability of 2 independent events is found by multiplying the probability of the first event by the probability of the second event. So we can understand it by looking at this in terms of a Venn diagram. The probability of independent events, if 2 events A and B are independent, then the probability of both events occurring is the product of the probability of A and the probability of B. So we're not talking about the possibility of A happening. We're not talking about the possibility of B happening, but rather we're talking about the possibility of them happening together, which gives us this green section. And what we do is we take the probability of A and multiply it by the probability of B. So here's an example. What's the probability of rolling an even number with a dice or a die and spinning an odd number? Well, when we look for the probability of it, we just have to take each of the probability of each event. So the probability of rolling an even would be 2 out of 6, or 1/3. And the probability of spinning an odd number is 4 out of 8, or in that case, 1/2. So to find the probability of rolling an even and spinning an odd, you would take the probability of the dice, multiply it by the probability of the spinner, and you would get the probability of 1/6. What would be the probability of pulling a jack out of a deck of cards and flipping a tails with a coin? In this case, it looks like a penny. Well, so we have 52 cards here, and out of a jack, only 4 are jacks out of the 52. So that gives us 4 out of 52. And the probability of flipping a heads is 1 out of 2. So when we multiply those together, we get 4 out of 104. And when we divide these, we get about 0.04, or in this case, 4%. So there's only a 4% chance that in random, you would pull a jack out of this deck and then flip a coin and get tails. Events that cannot occur at the same time are called mutually exclusive. Suppose you want to find the probability of rolling a 2 or a 4 on a die. We would write it as P parentheses 2 or 4. Since a die cannot show both a 2 and a 4 at the same time, the events are mutually exclusive. When we talk about mutually exclusive events, or compound probability, if two events, A and B, are mutually exclusive, then the probability that either A or B occurs is the sum of the probabilities. So we're looking for this or this. So in that case, the or indicates that we need to add those two probabilities together. So here's an example. Alfred is going to the Lakeshore Animal Shelter to pick a new pet. Today, the shelter has 8 dogs and 7 cats, and 5 rabbits available for adoption. If Alfred randomly picks an animal to adopt, what is the probability that the animal would be a cat or a dog? Since a pet cannot be both a cat and a dog, the events are mutually exclusive. So the probability that it would be a dog or a cat is 8 out of 20. And the probability that it would be a dog would be 7 out of 20. And I got 20 because it was 8, 7, and 5, which adds up to 20. So that was including the rabbits. So when I add these together, I get 15 out of 20, because when we add fractions, we just add the numerators, not the denominators. And that reduces down to 3/4. So picking at random, there is a 75% chance that Alfred would pick a dog or a cat. Here's another example. The French club has 16 seniors, 12 juniors, 15 sophomores, and 21 freshmen as members. What is the probability that a member chosen at random is a junior or a senior? Well, there are 16 seniors and there are 12 juniors. And if we add all these together, 16, 15, 12, and 21, we get 64. So the probability of being a junior is 12 out of 64. The probability of being a senior is 16 out of 64. We add those together, adding the numerators, not the denominators, and we get 28 out of 64, which reduces down to 7/16. We can also look at the probability of what's called mutually inclusive events or probability. So if, for example, looking at the probability of pulling a king or a diamond out of a set of cards. Well, the probability of pulling out a king, well, there are 4 kings in a set of cards out of 52. So that would be 4 out of 52. And then we would add that to the probability of pulling out a diamond. Now, the number of diamonds is 13, but since the king was also included, the king of diamonds was included, we can't say there would be 13, but rather only 12 out of 52. And we can reduce that down to 1/13 plus 12 would be 3/13. And we'd add that together to get 4/13. So there's only a 4 out of 13 chance that you would pull a king or a diamond. So let's practice some probability of compound events. We have cards and a coin. What's the probability of getting a heads and the probability of pulling a hearts? Well, the probability of pulling a heads is 1, or flipping a heads is 1/2. And since these are combined, we're going to multiply because we want both of them to happen. So we're going to do 1/2 times the possibility of a heart is 1/4. So the possibility of that happening is 1/8. What's the probability of pulling a tails, of flipping a tails and pulling out a 5 or a 4 from the cards? So again, the probability of flipping a tails is 1/2. The probability and times the probability of getting a 4 or a 5. Well, the probability of getting a 4 is 4 out of 52. The probability of getting a 5 is also 4 out of 52. So getting either of them would be 8 out of 52 because we're going to add those together. And that would give us the probability of 8 out of 104, which reduces down to 1 out of 13. And then finally, what's the probability of flipping a heads or a tails and flipping a face card? So the probability of flipping heads is or tails is 1. The probability of flipping a heads is half. The probability of flipping a tails is also half. So to get either of them would be 1. And to multiply it by the number of face cards, that would be, there are the king, the jack, and the queens. So king, jack, queens, that would be 12 out of 52, which reduces down to, or after we multiply, we get 12 out of 52, which reduces down to 3 out of 13. Okay, a couple more. We're going to roll an even number and spin an odd. Well, the probability of rolling an even is 1/2 times the probability of rolling an odd is going to be also 1/2. So the event that's going to happen is 1/4. Probability of rolling a 2 or a 3 and then spin a 7. Well, we have to add the probability of a 2 and a 3 first. So the probability of rolling a 2 is 1/6. Probability of rolling a 3 is going to be 1/6. So that's 1/3 together, times the probability of spinning a 7, which is 1 out of 8. And that would give us 1/24. And finally, to roll a 7 and then spin an even number. Well, the probability of spinning an even number is 1/2, but the probability of rolling a 7 is 0 because there's no 7 on the die. So we multiply those together and we would get 0. It is impossible for that to happen.